Hi there, Mr. Sutton here, bringing you the IM3 Chapter 1 Quiz 2 Review Solutions on piecewise and inverse functions.
For this problem, I've got this big piecewise function, and I'm plugging these 5 values into it. So let's start with f of negative 15. So the deal with all these problems is you have to look at the x value you're plugging in and see which of these ranges of x values it falls in. That tells us which of these 3 rules we're actually plugging the number into. So for negative 15, that's less than or equal to negative 10, so we're going to use this first rule here, which is one of those rules that it's so easy it's hard. This rule automatically gives you back negative 2 no matter what you plug into it, as long as you're plugging in something that's in this range of x values. So negative 15 gives you back negative 2. Negative 1 million would give you back negative 2. It's a constant answer. So for this next one, f of negative 10, that's actually right on the border between these 2 rules. So we have to be extra careful and look to see which rule negative 10 is included with. We see here that this first rule applies if x is less than or equal to negative 10, whereas this second rule, it's if x is greater than negative 10, if you want to read it from right to left there. So the equals is on this first rule, which means we have to use the first rule for f of negative 10, which means f of negative 10, like f of 15, is just going to be negative 2. f of 0. 0 falls between negative 10 and 3, so that's definitely the second rule we're using. So now we're going to actually plug something in for an x here. We'll have negative 2 times 0 plus 8, which is just going to be 8. Next, we have 3. 3 is right on the border between these 2 rules here, the second and third rule. Again, though, we have to go where the equals is. This second rule applies if x is less than or equal to 3. So we'll use the second rule again for 3. Negative 2 times 3 plus 8 is what we're doing here. So that's negative 6 plus 8, which is positive 2. Finally, we've got f of 10, and that definitely falls in this third rule where x values are bigger than 3. So we're going to be doing 10 minus 10 squared for this last one. That's 10 minus 100, which gives us negative 90. For this one, we're trying to graph this piecewise function. So the way this is set up is we've got 2 lines. The first rule here is a horizontal line. The second rule is a slanted line. Basic idea, though, is that one line keeps going until we get to the x value 4. And then at 4, this other line takes over. So what I want to do to start this off is I want to figure out where this first line ends, the point at which this ends, and then I'll work my way backwards and graph the rest of it. Then I'll move on and deal with the second line. So to figure out where this one ends, the x and y value, the point where this first one ends, I'm going to plug the border value 4 into this first function. Now, doing that is kind of it's kind of funny because we can only get 6 back. So when I plug in 4, I get 6 back automatically because this is a horizontal line. So my first endpoint then is 4 comma 6. Now I have to figure out if this is an open or a solid dot. And to get that, I look at whether 4 for this first rule is included in the interval. Now it says x less than 4, not equals. There's no equals here. So that means that I have to use an open dot for this first rule's endpoint. So these grid lines are going by 2s. We're going to go over 4, up 6, open dot right here. Next, to graph the rest of this, I mean, it's a horizontal line. We've got a slope and m value of 0. So I just have to go horizontally backwards from this open dot I just drew, and I'm going to go forever. I'll have an arrow to signify that, because this is all x values less than 4, all the way back to negative 3 trillion and even beyond that. Next up, I'm going to take care of this second rule. I have to figure out where this second rule starts as well. I can't just assume that it's starting where this first rule left off, this open dot. It may not, I don't know. I have to plug 4 into this second rule as well to figure out the point, the y value, that this one is starting at. So plugging 4 into this, I've got negative 1/2 times 4 plus 5. That's going to be negative 2 plus 5, which gives me 3. So that means I have the point 4 comma 3. Now because we said x greater than or equal to 4, because we have the equals, this 4, 3 point is going to be a solid dot. So we are going over 4, up 3, solid dot right here. Now we have to do one more dot to draw this line, one more point. I think the easiest one to use here is going to be the next point I get with this slope of -1/2. So I'm just going to start at this dot I just drew and go down 1 over 2, just following the slope. Here's another point, and I'm just going to draw a line going through those points. Now remember, this line starts at this first solid dot and goes through all the way here. And there's our piecewise function. For the next few problems, we're being asked to find a rule for f inverse of x, or to state that there is no inverse. So let's take a look at our first problem here. This one, we see that we have an even power right here, this fourth power. Even powered functions do not have inverses. They're not one-to-one functions. That is to say that there are multiple inputs that give you the same output. So if I tell you the output, you don't know which input to use. Negatives and positives, for example, would both give you the same answers on these. So there's no inverse for this one. For this problem, we're trying to find the inverse. Doing a quick check, there's no absolute value or even exponents to mess us up on this one. So we can go ahead and find the inverse. We'll start by switching the x and the y values and then solving for y. So instead of writing f of x or y right here, I'll write x equals y plus 6, all that raised to the 7th minus 12. And now we'll go ahead and solve for y. To do that, the first thing we have to do is add this 12 to the other side. And now we have to get rid of this 7th power. We can do that by taking the 7th root of both sides. So we have 7th root of x plus 12 equals y plus 6. And then as a final step, we'll subtract 6 from both sides, and I'll just write f inverse of x equals 7th root of x plus 12 minus 6. For this problem, we're trying to find the inverse. That's actually going to be a little bit difficult because we have this absolute value. Absolute values are not one-to-one functions. If I plug in negatives or positives, absolute value ends up giving me the same answer for multiple inputs. So because of that, if I tell you the answer, you don't know how to go backwards and tell me which input it was that gave you that answer. So long story short, absolute value, even exponents, those types of things do not have inverses. Another way to think about this, since we know our function families now, is that absolute value functions fail the horizontal line test, which is a test to see if you have an inverse. If you have a horizontal line that touches twice, your function will not have an inverse. To find the inverse on this function, we're going to go ahead and switch the x and y values. So I'll write x equals 8 over y minus 1 plus 6. And now I have to get y by itself. First step to doing that is to subtract this 6 so I can isolate that fraction. And at this point, I would prefer y to not be in the denominator, so I'm actually going to take the reciprocal of both sides of the equation. So on the left side, I'll have 1 over x minus 6. On the right side, I'll have y minus 1 over 8. So reciprocal for both sides. And again, the only reason I did that is to get y in the numerator, because it's easier to solve for it when it's in the numerator. Next, I'm going to get rid of this 8 by multiplying it to the other side. And finally, I'm going to add 1 to both sides, giving me f inverse equals 8 over x minus 6, all of that plus 1.